Welcome to the calculations of confidence intervals. Right, so I'm going to read the question, but I'll also screen the question. So it says, a wine importer needs to report the average percentage of alcohol in bottles of wine. From experience with the previous kinds of wine, the importer believes the population variance to be 1.44. The importer randomly samples 60 bottles of new wine and obtains a sample mean of 9.3%. Calculate a 90% confidence interval for the average percentage of alcohol in all bottles of the new wine. Use a critical value of 1.645. Right, so what we need to be able to do is to list the things that we see as we read the question. So as you read the question, let's identify the things that stand out. So we're going to pick the key things. The one thing that I'm picking first is the population variance. So the population variance, so this is sigma squared is equals to 1.44. We move again, the importer randomly samples 60 bottles, so our n is equals to 60. Also says a sample mean x bar is equals to 9.3%. And then we're given the 90% confidence interval. 90% confidence interval, which equates to a z value of 1.645. So when you look at the information that you're given here, it actually speaks a lot to the kind of question that you're answering. So you are answering what we would call a quantitative kind of question. Alright, so if you go down to your formula sheet, you should find under number 5 the confidence interval formula. You select the one that speaks with one population and also one that is quantitative. So what you're going to do now is to write down the formula. So if you go down to the formula sheet, you see that it says x bar minus, right, a z multiplied by sigma over the square root of n is less than or equals to the population mean mu, which is less than or equals to x bar plus z multiplied by sigma over the square root of n. So having put the formula down, the next thing is to substitute, which is going to be the easier part. We have already written a key of what we got from the reading of the story. There's only one bad problem. If you look at this, this is the population variance. When you look at the formula, it doesn't have the population variance. What is there is the population standard deviation. So we need to convert this. So how do you convert the sigma? Simply take sigma squared and you find the square root of 8. It will give you your sigma. So sigma is equals to the square root of the sigma squared, which is 1.44, and the square root of 1.44 will give you 1.2. Of course, you can use your calculator. 1.2. This is the population standard deviation. So now we are ready to rock and roll. Substitute. So substituting, x bar would be your 9.3 minus z is 1.645 multiplied by sigma, which is now the 1.2 over the square root of n. This is less than or equals to the mu, which is not going to be more than 9.3, substituting your x bar, plus 1.645 multiplied by 1.2 over the square root of what? Of n. We've got our substitution. So what we just need to do now is to punch in the calculation and see the answers we get. I would recommend that you start working out this part and then you can minus it from 9.3, and then you can add it to 1.3, because this part and this part are essentially the same. After having done your calculation, you're going to see that the mu on the top part is 9.55, we can round it off to 5, and just the lower part here, we're going to say 9.3 minus 1.645, right, minus, that will give you a 9.045. So this is the solution. So where are the marks? The marks are in number 1, knowing the substitution, knowing your formula, knowing how to substitute, and we're going to have 2 marks for the lower limit and the upper limit. So essentially this question is going to carry about 2, 4, 6, but of course this one is 10, so you would get another mark for this here and that here, so that makes 1, 2, 3, 4, 5, 6, 7, maybe the noting there, 8, and most probably there's going to be 2 marks here and 2 marks there. That would make your 10 marks. That's how you would calculate this question. So we move into the calculation of the qualitative side, and we see how that differs from this quantitative side. Okay, but when you read the question, take note of what is happening, and then it makes it easy for you to know which formula you're going to pick as well. If you go under confidence intervals, then you should see the one that has the variables that you have listed here. If not, then that will be the wrong formula. Confidence interval still. Let's read the question, understand the question, and then we begin to answer the question. Question number 3 says, the Department of Trade and Industry, DTI, wants to determine the percentage of manufacturing firms that have met the Employment Equity Charter. In an attempt to assist the department, Statistics South Africa, Stats SA, selected a random sample of 200 manufacturing firms and established that 84 have met the Employment Equity Charter. At 95% confidence level, create a confidence interval for the population of manufacturing firms that have met the Employment Equity Charter. Use limits of plus or minus 1.96, and this is an 8-mark question. So how are we going to start? The first thing that we're going to do is to determine whether this is a qualitative or a quantitative question. It's either the companies have met the charter or they haven't met the charter. This makes this question qualitative. And if you look at it, it has given you a fraction or a proportion of the firms that have met the charter. So when we are answering such questions, we must first understand what the question is seeking and know also the information that we're given. So from the information that we're given, we're going to take it down and write it down so that we know what we're doing here. So the first thing that we're going to read through and point out is that the random sample of 200. So our n is equals to 200. That is the random sample that we're going to be using. And it says 84 have met. So 84 have met. So this is actually a proportion. 84 out of what? 84 over 200 have met. So this is our P. So our P is equals to 84 over 200. That's the proportion that have met. And we're going to say we are estimating at 95% confidence interval, which gives us a Z value or a critical value of 1.96. So we've got the information that we need to be able to calculate. So what you would need to do is to move and scroll down to your formula and check what your formula says. That will be under section 5. If you're using this formula that we're using here, show you the formula, and I'm going to take it down. So you go under confidence intervals, and under confidence intervals you're going to see that there's several questions. There's one with X bar, there's one with the T. We want to use the one with the proportion, and this is a one population. So the formula that you're going to select is the one that says P minus Z multiplied by the square root of P1 minus P over N is less than or equals to the population pi, not mu, because this is qualitative data. Less than or equals to P plus Z multiplied by the square root of P1 minus P over N. So do we have enough information to substitute? We go back to our P, we can change the P. Make sure that your P corresponds with what you're required to calculate. The 84 have met the requirements or the equity charter. Read the question. At 95% confidence level, create a confidence interval for the population of manufacturing firms that have met. So this P is still fine because we're talking of that have met. If it says that have not met, then we're going to change this fraction. So this is 84 divided by 200. That will give you 0.42. So our P is 0.42 in terms of a fraction. This is what we're going to use, the decimal fraction. So now we need to substitute. So we are going to say 0.42 minus Z, which is the critical value, 1.96, multiplied by the square root of 0.42, 1 minus 0.42, divided by N. What is our N? Our N is 200. And then this is less than or equals to the pi, which is less than or equals to 0.42 plus 1.96 multiplied by the square root of 0.42, 1 minus 0.42, all over 200. So now let's be trigger happy, calculator happy, and punch this into our calculator. So I would first say the square root and put a bracket there, and then you can put your fraction there, 0.42 in brackets, 1 minus 0.42, and then you divide this by 200, and then you say, okay, just a slight error there. Okay, just the calculation, 0.42 in brackets, 1 minus 0.42 or under the square root, which is divided by 200, and then we multiply by 1.96, and then we would store this in A, because the answer is the same as on that side. So on the first part, I'm going to say 0.42 minus the answer. So it's going to be 0.42 minus, recall what I put in A. So this is 0.3368, which is less than or equals to the pi, which is less than, which is not more than 0.42 plus the calculation, which is 0.503, let's just say to the nearest. This is our answer. So what does it mean? It means to say that we can change this into a percentage and say between 33.68% and 50% of the firms have met their employment equity charter. That's how we're going to do that calculation. Done. So where are the 8 marks? there's going to be 2 marks here. That's 1, 2, and 3 for the formula, and then the other 5 marks would be in the substitution here. So most probably 1, 2, and 3. That makes 2, 4, 6, and then of course this is essentially the same. So essentially like 4 marks for this, 2 marks here, and 1 mark there, and then your substitution as well needs to be shown when you're reading the question. That's it. Another question, another example of confidence intervals. You know, the thing is, the more you practice, the more you understand. So reading the question, it says, a national bank analyzed a random sample of 365 check accounts in their Tshwane branch and found that 78 were overdrawn. Okay? By leaving your answer to 2 decimal places, estimate with 95% confidence the percentage of all bank accounts at the Tshwane branch of the bank that were not overdrawn. Right. Hint, use a critical value of 1.96. How do we do this? First, we determine whether the data is qualitative or quantitative. So it's either an account is overdrawn or in good standing order. This makes it qualitative. There is no average that has been given. If they say the minimum amount that should be kept in a bank account is, say, 5,000, then we'll be dealing with a quantitative issue. But this is a qualitative issue. So let's take down the stuff and write them on the board. So the random sample, your n is equals to 365 check accounts. 78 were overdrawn. 78 are overdrawn. Okay? And then we are using 95% confidence interval, and this is going to equate to a Z value of 1.95. What else are we given? That's all. That is enough as well. So what we need to be able to do is to know, okay, what question we're doing. We say we're looking at qualitative data, and on the last part of the question it says, by leaving your answer to 2 decimal places, estimate with 95% confidence the percentage of all bank accounts at the Tshwane branch of the bank that were not overdrawn. So if 78 are overdrawn, how much is not overdrawn? This leads us to saying our P would be 365 minus 78, which were overdrawn, over the 365. This would give us our fraction. 365 minus 78 would be 287. 287 over 365. This is the portion or the proportion that we are supposed to be working with, and this divided by 365 would give us a fraction of 0.78. It has been said how many decimals here, so we're just gonna use the 863. Let's use it with the 4 fractions, and then we are going to put in the formula. Our formula under the confidence interval, looking at qualitative data, would say P minus Z multiplied by the square root of P, 1 minus P over N, less than or equals to the population parameter, which is pi, which is also P, plus Z multiplied by the square root of P minus P bracket 1 minus P over N. Let's substitute. We do have our P is 0.7863 minus the Z 1.95, This is multiplied by the square root of 0.7863, 1 minus 0.7863, all over n. Our n is 365, and then this is less than or equals to the pi, which is less than or equals to 0.7863 minus the square root of the same calculation here, 0.7863, 1 minus 0.7863 over 365. So coming to this side, just the calculation there, we're going to say 0.7863. Just gonna store it in my memory so that I don't keep on punching the same figure. So I'm gonna do the square root now. Square root of, recall A, 1 minus, recall that 0.78, right, and then all this is divided by 365, and then this is multiplied by 1.95. we are going to get a 0.04. So we're going to add it to the 78%. Or the first one we subtract. So minus that would give us 0.7444, essentially. Less than or equals to the pi, which is less than or equals to 0.8281. So we can conclude that 74%, between 74% and 80, rounded off 83%, but I would prefer that you show the answer here. What I'm just trying to say is between 74 and 83% of the bank accounts are or were not overdrawn, this is key because essentially they had given you a proportion of 78 out of 365, which were what? Overdrawn. So if you do that calculation, 78 divided by 365, you get a percentage of 21%. So 21% were what? Were overdrawn. So not overdrawn would be about 79% from the original calculation. So with our 95% confidence interval, we can estimate that between 74% and 83% of the accounts were not overdrawn. That's how you do the calculation. Thank you.